If you're a science fan, you need to hear this. Because today, we're diving into one of the most elusive and mysterious puzzles in all of physics. Imagine a particle so tiny, so slippery, that it can pass through light years of solid lead without ever interacting with a single atom. That's the neutrino, often called the ghost particle of the universe. For decades, scientists have been on a quest to understand these enigmatic particles, and now, we're closer than ever to unlocking their secrets. Physicists have finally made groundbreaking progress on weighing the universe's most mysterious particle, neutrinos. This isn't just a small step for science, it's a giant leap for our understanding of the cosmos. For years, the mass of the neutrino has been one of the biggest unanswered questions in particle physics. And now, thanks to the dedication and ingenuity of researchers around the world, we're finally starting to get some answers. Get ready for some cosmic detective work because the story of the neutrino is like a real-life science thriller. Picture a team of scientists armed with the most advanced technology on Earth trying to catch a particle that barely leaves a trace. It's a challenge that has pushed the boundaries of human knowledge and technology, and the results are nothing short of astonishing. Neutrinos are called ghost particles because they're almost impossible to catch. They barely interact with anything, matter, energy, even the forces that govern the universe. In fact, a single neutrino could travel through a wall, a planet, or even an entire galaxy without ever bumping into anything. That's why, for so long, they've remained one of the greatest mysteries in science. Right now, as you're watching this, trillions upon trillions of neutrinos are flying through your body every single second, and you don't feel a thing. They're so tiny and so non-interactive that you could live your entire life without ever noticing them. Yet despite their ghostly nature, neutrinos are everywhere, constantly streaming through us from the farthest reaches of the universe. So where do these ghostly particles come from? Neutrinos are born in some of the most extreme environments in the universe. They're created in the heart of the sun, during the process of nuclear fusion that powers our star and gives us light and warmth. They're also produced in violent cosmic events like supernovae, when massive stars explode at the end of their lives, sending shockwaves and neutrinos racing across the cosmos. Even here on Earth, nuclear reactors are busy churning out neutrinos as a byproduct of their energy production. But here's the catch. Despite knowing so much about where neutrinos come from and how many there are, we never knew their exact weight. For decades, physicists could only guess at how much mass a neutrino might have. This might sound like a small detail, but in the world of particle physics, even the tiniest mass can have huge implications for our understanding of the universe. And that matters, because figuring out their mass could help us crack some of the biggest mysteries in science, like what dark matter is made of, how the Big Bang unfolded, and why the universe even exists the way it does. Neutrinos might hold the key to understanding why there's more matter than antimatter, why galaxies form the way they do, and even what the ultimate fate of the universe might be. In other words, by weighing the neutrino, we're not just solving a physics puzzle, we're unlocking the secrets of existence itself. Now, after years of painstaking research, scientists at the Katrine experiment in Germany have just set the most precise upper limit ever on the neutrino's mass, less than half an electron volt. To put that in perspective, the Katrine experiment is a massive state-of-the-art facility designed specifically to hunt for the tiniest traces of neutrino mass. It's a testament to human curiosity and ingenuity, bringing together experts from around the world to tackle one of the universe's greatest challenges. For context, that's millions of times lighter than an electron. Imagine weighing a grain of sand and then trying to measure something a million times lighter. That's the scale we're talking about. The fact that we can even detect something so minuscule is a triumph of modern science and technology. So how did they do it? The Katrine team pulled this off by tracking tritium atoms as they decayed, a process that releases neutrinos, and using ultra-sensitive spectrometers to measure the energy of the particles involved. By analyzing the tiniest changes in energy, they were able to set a new record for how light a neutrino could possibly be. This kind of precision requires not just cutting-edge equipment, but also years of careful calibration, data analysis, and teamwork. But the story doesn't end here. Even bigger and more ambitious detectors are on the way, like Project 8 and the Deep Underground Neutrino Experiment, or DUNE. These projects are pushing the boundaries of what's possible, using new techniques and even larger detectors to try to pin down the neutrino's true weight once and for all. Scientists are racing to build the next generation of experiments, each one more sensitive and powerful than the last, all in the hope of finally solving the neutrino mystery. Why does this matter for you and me? Because the answers we find about neutrinos could reshape our understanding of the universe. If we can measure their mass precisely, we might finally understand how galaxies formed after the Big Bang, or why the universe is expanding the way it is. Neutrinos could even help us discover new physics beyond what we currently know, opening doors to realms of science we haven't even imagined yet. And there's more. Neutrinos are known to oscillate, or change flavors, as they travel through space. This strange behavior hints at physics beyond the standard model, the framework that describes all known particles and forces. By studying neutrinos, we're not just learning about one particle, we're probing the very foundations of reality itself. So next time you look up at the stars, remember, the universe's tiniest ghosts may hold its biggest secrets. Every second as you gaze into the night sky, you're being showered by particles that could answer questions as old as time itself. The quest to understand neutrinos is a testament to human curiosity, creativity, and our relentless drive to explore the unknown. Want more cosmic mysteries? Hit like, subscribe, and drop your neutrino theories in the comments. What do you think the next big discovery will be? Could neutrinos hold the key to dark matter, or even parallel universes? Join the conversation and let's explore the universe together, one ghost particle at a time.